this is the structure of your glucose. And in case of whole degradation, you are treating it with hydroxylamine and this sodium methoxide. So what will happen? This hydroxylamine, this NH2 group will condense with this carbonyl group. So you will get this imine structure. And then if you treat with acetic anhydride in sodium acetate and acetic acid mixture, then you will get OAC here. This OH will be converted into OAC, and this C11NOH will be converted into CN. Then treat it with sodium methoxide in the methanol, then you will get an aldehyde. But this is actually a lower one because this carbon is forming the aldehyde here. This is actually almost similar to the rough degradation, but the process is a little bit different, and here the hydroxylamine is being used. So you are converting a aldohexose to a aldopentose by whole degradation. Now this is the detailed mechanism of the transesterification. What is the transesterification? The transesterification means, assume that you have one ester and you are reacting it with another alcohol. Then you will get the corresponding ester. So from one ester you are getting another one ester. This is called transesterification. Now this is the mechanism of the whole degradation. In case of this whole degradation, one process involves the transesterification. Just watch it carefully. The OMe group is attacking here. This bond is being opened. Then what is happening? This O minus is coming back. Then this bond is being broken. Ultimately this group is being removed. So ultimately this group is being removed and this O minus is taking a proton here. So you are getting CHOHCN. And after that this hydrogen also leaves by taking this cyanide as HCN, and you will get a lower aldehyde. This, if it has n number of carbon atoms, this will have n-1 carbon atoms. Weerman degradation. Weerman degradation is named after Rudolf Adrian Weerman, who discovered it in 1910. The reaction is used for the degradation of alpha hydroxylamide. It proceeds very slowly at room temperature. Therefore, the reaction mixture is heated up to 60 to 65 degrees centigrade. This is the general reaction scheme of Widman degradation. Just watch it. This is your alpha hydroxylamide. This is the amide group CONH2, and in the alpha carbon there is a hydroxyl group. That's why this is a alpha hydroxylamide. And just treat it with NaOCl. NaOCl means the combination of NaOH and Cl2. This will form the NaOCl. So you will get this aldehyde, RCHO. The first step of Weerman degradation involves oxidation of the aldose with bromine water, followed by acidification to yield a lactone. The lactone is then heated with ammonia to give an amide. This alpha hydroxyamide is finally treated with Cl2 and NaOH. to give a new lower carbon sugar. This will be alpha, okay, not A. The reaction mechanism is related with Hoffman degradation. So just see the reaction mechanism here. At first you are treating with bromine water and then acidifying, so you are getting a gamma lactone, and then heating with ammonia, so you are getting an amide, CONH2 amide, and then you are treating with NaOCl, that means the NaOH plus Cl2, then you will get an isocyanate which will form D-arabinos, that means which has one carbon less than this one. Okay, this is the reaction mechanism of alpha hydroxyamide. At first this base will take up this proton and this NH will become minus, then this NH minus will take one chlorine and become CONHCl, then another one OH minus. What it will do? Okay, it will take this hydrogen. This OH minus will take this hydrogen from this nitrogen, and this nitrogen will become minus. Now this will give electron here, and this carbon-carbon bond will be broken, and this bond will be transferred to the nitrogen. So this structure will form after rearrangement. Then this OH minus will take up this proton, and this bond is going here, and this one will be free. So you are getting finally an aldose. If there is no free hydroxyl group on the alpha carbon atom, that is the atom is attached to a methoxy group, then treatment with alkaline sodium hypochlorite produces an aldehyde, methanol, ammonia and carbon dioxide. That means there is no free hydroxyl group on the alpha carbon atom. This is the alpha carbon and there is no free hydroxyl group. So now if you just try to do the Weerman degradation, you will get the aldehyde and this methanol, ammonia and carbon dioxide. Weerman degradation could also be executed with alpha-beta unsaturated carbonic acid amides. For example, it can be done in acrylamide. So if you are interested, you can see this mechanism also. I am not going in details because this is not necessary in this stage in case of carbohydrate chemistry, but if you are interested in this kind of mechanisms, you can see it.